Welcome to more examples of the inverse Laplace transform. So in this example, we are to find the inverse Laplace transform of f of s equals 6s minus 8 over s plus 2 cubed. So the first thing to denote here is our denominator is in factored form. And it just has one root, right? We've got that repeated root of -2. So let's just see what we can find. So we'll check the table. For something of the form something, whatever, over s minus a to the k or to the n. And we'll see what we wind up with. So going back and taking a look at the table. Looking at this table, we do have a row that t to the n times e to the at row. We have an s minus a over some power of n down below. So in this case, it's an s minus a to the n plus 1, but that will take care of our powers. And we also have the e to the at corresponds to 1 over s minus a. Notice neither of these have any s's in the numerator. So let's go ahead and transfer these two forms back to our notes. And these are our two forms. So note neither form has any s's in the numerator. So we are forced to use partial fractions to sort of change the format of our original function. That's 6s minus 8 over s plus 2 cubed. We're forced to use partial fractions to break this up into individual fractions, none of which involve an s in the numerator. So we need to use partial fractions. We need to use partial fractions to break up f of s equals, what was it, 6s minus 8 over s plus 2 cubed. Yes, into forms that we can recognize. So into one of the above forms, or into the above forms. I need to give myself a little more space. So anytime we have a repeated root in our denominator, we can break this up into fractions where we essentially take all the possible powers, lower powers and current power for the denominator. So we are going to re-separate this as a over s plus 2 plus b over s plus 2 squared plus c over s plus 2 cubed. Usually if we have a quadratic or a cubic in the denominator, then our numerator would need to be the generic polynomial of one lower degree. But in the case where we have repeated root, as we take our consecutive powers, we can continue to just have constants in the numerator. Then we will have 6s minus 8 up top over s plus 2 cubed. So this is equivalent to a times s plus 2 squared plus b times s plus 2 plus c is equal to 6s minus 8. Sorry about the break. So from here, we have some tricks that we can play. So first thing we can do is we can note that since there's no s squared term on the right, a has to equal 0. Right? So since the right-hand side has no s squared term, we know immediately that a has to equal 0. So we get from here that b times s plus 2b plus c has to equal 6s minus 8. Matching coefficients. Then we get that b should be equal to 6. And then 2b plus c, or 12 plus c, should be equal to negative 8. And that therefore means that c should be equal to negative 20. So we wind up with our f of s is equal to, we have 6 over s plus 2 squared, or 6 times 1 over s plus 2 squared is probably the 6 times 1 over s plus 2 squared, and then we have minus 20 times 1 over s plus 2 cubed. Now, if we scroll back up to what the table said, we are looking for n factorial over s minus a to the n plus 1. So we want n factorial over s minus a to the n plus 1. So in this first one, we're looking at n equals 1. On the second one, we are looking at n equals 2. Right? So we want 1 factorial over s minus negative 2 raised to the 1 plus 1. 1 factorial is just 1, so we can leave the 6 out front. The second one, we are aiming for 2 factorial over s minus negative 2 to the 2 plus 1. That 2 factorial accounts for times 2, so we have minus 20 over 2 factorial out front to counteract that 2 factorial we put in. Technically, we could write the first one as a 6 over 1 factorial if we wanted. At this point, we have just f of s is equal to 6 times this first one is the Laplace transform of t to the n, so t to the first power, times e to the at, so times e to the negative 2t. Then we have minus 20 divided by 2 factorial is minus 10. That 2 factorial over s minus negative 2 raised to the 2 plus 1. We are looking at the Laplace transform of t squared times e to the negative 2t. Again, we're essentially going backwards, right? Going from the n factorial over s minus a raised to the n plus 1 back to t to the n e to the at. At this point, we are essentially to the finish line. We can just get to our f of s. I need to give myself a little more room. Taking the Laplace transform, the inverse Laplace transform, we have the inverse Laplace transform of f of s is lowercase f of t, which is just 6t e to the negative 2t minus 10t squared e to the negative 2t. So again, this was taking that inverse Laplace transform. It required a bit of algebraic manipulation in order to do the problem. We'll do one more example in the next video.